Here's my example of a GCF factoring, greatest common factor we're going to pull out. Later on when we're dealing with trinomials, there's another method that might work, but I've designed this one so it's just the greatest common factor that we're looking for. So to find out what the greatest common factor is, I would do it a piece at a time. Start with the numbers, see what you can pull out of each one of 18, 12, and 6 here. So the largest numerical greatest factor of these three numbers is just 6. So we'll pull out the 6. And then we start with the variables x cubed, x squared, and x. General rule of thumb is you want to pull the smallest powered variable out, which happens to be this x right here. So we're going to kick out the x also. And then the y squared, a y cubed, and a y squared. Well, the lowest powered y is going to be y squared. Now when you leave things behind in the parentheses after this factoring, the operation that lets you figure out what's left behind is technically division. So here we have 18 divided by 6, that'll be 3. We have x cubed divided by x, that'll leave us with a x squared. Y squared divided by y squared is 1, and 1 times 3x squared is just plain old 3x squared. Next term will be a positive 12 divided by a positive 6 will be a positive 2. X squared divided by an x will leave you a factor of x. Y cubed divided by y squared will leave you a factor of y. And then we move on to the next term. Negative 6 divided by positive 6 is negative 1. X divided by x is 1. Y squared divided by y squared is 1. So what's left behind here is a negative 1. Technically, negative 1 times positive 1 times positive 1. So this would be the greatest common factor pulled out of this trinomial. One thing to really notice is, even though I pulled out a term, what's left behind is still a trinomial. And that's just in case you start losing terms. And that's our answer. Done.